Hi guys, let's look at the next exercise. Next exercise is exercise 14C. But before we start the exercise, let us revise quickly what all we've learned in this chapter yet, because there is no new concept that I need to teach you for this third exercise. So let's revise. So sum of all interior angle for all polygons is given by n minus 2 into 180 degree, or some people can also write it as 2n minus 4 into 90 degree. Next, sum of all exterior angles of a polygon is 360 degree. This is always taken in order. So even if taken in order is not written, it means that it is taken in order. Interior angle plus exterior angle is always equal to 180 degree because it forms a linear pair. Each exterior angle of a regular polygon. Now these are applicable only for a regular polygon, since 360 degrees is the sum of all angles and there are n angles in a regular polygon and all angles are equal, then each exterior angle is equal to 360 degree upon n. And for interior angle for a regular polygon, it will be n minus 2 into 180 degree upon n, or 2n minus 4 into 90 degree, whichever way you look at it, upon n. Good. So let's look at the next one, which is properties of diagonals. In a parallelogram, diagonals bisect each other, and all these are a type of parallelogram. Rectangle, rhombus, and a square are type of parallelogram, which means the diagonals bisect each other. Are the diagonals equal? The diagonals are equal only in the case of a rectangle and a square, which means both the figures which make a vertex angle of 90 degree. Do diagonals bisect vertex angles? Not in case of a parallelogram, not in case of a rectangle, but only in case of a rhombus and a square, which means both the figures which have all four sides equal. In those cases, the diagonals bisect the vertex angle. And our diagonals perpendicular to each other, again these are perpendicular to each other only if it's a square or a rhombus, which means all four sides are equal. Good. Let's look at the next part and then we can start solving some questions. So question number 2. The question number 2 says the diagonal BD of a parallelogram ABCD bisects angle B and angle D. Prove that ABCD is a rhombus. So we know this is a property. If it's bisecting the vertex angle, it will either be a rhombus or a square. So this time they are asking us to prove it's a rhombus. So let me just draw a rough diagram and see how it will look like. Good. So I am trying to draw a parallelogram. Yeah, it looks something like this. This is A, this is B, this is C, this is D. A diagonal BD bisects vertex angle B and D. Good. So which means whatever is this angle, the same as this angle. Similarly, these two angles are also equal. And vertex angles, opposite angles are already equal, which means all of them are equal. Let's write this down. So in the given parallelogram, number 1, this side and this side are equal, this side and this side is also equal because it's a parallelogram. So let's just write that down. AD is equal to BC and AB is equal to CD. Number 3, angle ABC is equal to angle ADC. This is properties of parallelogram, which is vertex angles are equal. So in this case, D and B are equal, and similarly the opposite sides of a parallelogram are equal. So number 4 would be half of angle ABC will be equal to half of angle ADC, right? Which is, let angle ABD is equal to X. Therefore, angle ABD is equal to angle DBC is equal to angle ADB is equal to angle CDB is equal to X. So all four side, all four angles are x. Now let's look at this triangle ABD. So this is point number 6. In triangle ADB, what do I get? Angle ADB and angle ABD are equal. Why are they equal? Because we've already done this in point number 6. So from 6. Therefore, triangle ADB is isosceles and AD equal to AB. So now I had put two lines here. Let me just cancel it. It is single line, right? And I know that AB and DC are equal, which means this is also a single line, which means this is a rhombus. So let's just write that down. From 1 and 2 and 8, we get AD is equal to BC. AD is equal to BC, but we get AD is also equal to AB from 8, which is AB, and I know that AB is equal to CD. So this is equal to CD. So this is point number 9. Since all sides of parallelogram ABCD are equal, therefore quadrilateral ABCD is a rhombus. Perfect. So here we used one property, which was that the vertex and opposite angles are equal. So both the half of the vertex angle will be equal. That's one property we used. The second property we used was opposite sides of a parallelogram are equal. And the third property we used was a isosceles triangle, which means these two sides are equal. Perfect. Let's look at the next question. The next question that we do is question number 3. Question number 3 says the alongside figure shows a parallelogram ABCD in which AE is equal to EF is equal to FC, which is already marked. Prove that DE is parallel to FB. Perfect. And we also have to prove that DEBF is a parallelogram. So let me just join that and see how will it look like. So this is DEBF. We need to prove that this is a parallelogram. Let's see information that we already know, which will help us figure something out. So I know that this side and this side are equal. I know AB and CD are equal, right? I know this angle and this angle will be equal, which means this angle and this angle are equal. Why? Because these are alternate angles. So can I try and prove something in some triangle? I think I can prove ABE and BFC congruent by side angle side. It will help me somehow. I think it will, because this will help me prove that DE and FB are equal. Perfect. So let's start looking. In triangle ADE and triangle CFB, I'll draw a rough diagram for us to understand it more clearly. This is D, E, and A, and this is F, C, B. This is F, this is C, this is B. In this, I know AD and BC are equal, AE and FC are given equal, and I know that angle DAE and angle BCF are equal. So let's just write all this down and see how we can move ahead from here. So number 1, AD is equal to BC. Number 2, AE is equal to FC. And number 3, angle DAE is equal to angle BCF. This is alternate angles are equal. In this case, given, and this is opposite sides of the same parallelogram. So opposite sides of the same parallelogram are equal. Therefore, by side angle side test, triangle ADE is congruent to triangle CBF. Let's check AD and CBF. Perfect. Which means this is point number 4, which means I can get DE is equal to BF. So I get DE and BF are equal. How does it help me? I can get DE and BF equal. These are opposite sides of this parallelogram and they are equal. If I can prove that they are parallel as well, yes, I think I can prove them parallel because this angle and this angle are also equal and these are exterior alternate angles. Perfect. So then I can prove that these two sides D and PF are parallel. Perfect. Number 6 that I get is angle AED is equal to angle CFB. This both of this is CPCTC. Done. Now let's see how we can move from here. Number 7. For BF and DE and FE as transversal. So I'm looking at, let me just highlight this with different colors so that you know which lines I'm referring to, and I'm referring to this as the transversal. This angle and this angle are exterior alternate angles. So let's just write them down. For as transversal, angle CFB and angle AED are exterior alternate angles, and since they are equal, how are they equal? From 6, therefore BF is parallel to DE. This is my point number 8. So from 5 and 8 I get BF is parallel to DE and BF is equal to DE. Since one pair of opposite side is equal and parallel, therefore quadrilateral BEDF is a parallelogram. Perfect. So let's look at this question once again. We looked at these two triangles. We proved that these two triangles are congruent. It gave us that this side and this side is equal. It also gave us one angle equal. We realized this angle is the exterior alternate angle. So that's how we got that these two sides are equal. These two sides are equal and parallel, which helped us to prove that this is a parallelogram.